So, children, we studied that current is of two types, and that is AC and DC. Now, especially when we were studying about AC current, we studied AC means alternating current, a current in which the direction of current keeps on changing. The current flows in one direction, then current flows in another direction. Now, how is this possible? And how exactly does an AC generator work, right? Now, to understand the working of an AC generator, let us enter into MT Educare Science Lab. This is a virtual classroom for you, right? So let us look at this particular science lab. Of a AC generator, the first part is a armature coil, right? Children, we had seen this armature coil in a motor also. So what is armature coil? It is a rectangular metal slab on which there is a coiling of copper wire. So copper wire is coiled on a rectangular metal slab, and this is called as a armature coil, right? We'll go to the next part. These are the pole pieces of a magnet. A pole piece of a magnet means if that side is a north pole, then the other side there should be a south pole, and this is south pole, that side should be a north pole. So either in such a instrument a pole pieces of a magnet is taken, or you can also take a horseshoe shaped magnet, right, with only the poles which are kept here, right? So either of the thing can be taken. We'll go to the next. This part is called slip ring. It plays a very important role. Inside, you can see, inside the slip ring are the two wires, and these wires can slip through this particular rings, and that is why these rings are called as slip rings, right? Here are the brushes, right? This is a brush, and after this brush is the galvanometer. We know galvanometer is a device which measures the direction of current, and also galvanometer is a device which shows the current and also detects the direction of current, right? Going further, let's see this. Now taking a look at the slip rings from inside, you can see one of the wire is a shorter wire, and the shorter wire is connected to the first of the slip ring. The longer wire is connected to the second slip ring, right? That is how they are connected from inside. Going further, you can see that there are lines of force. The lines of force are starting from north and going to south. So as soon as the armature coil ABCD is going to rotate in the magnetic field, what is going to happen? As soon as it rotates, first thing is lines of force are cut, right? The second thing that happens is the magnetic field in the armature coil changes, right? And because of this, current is induced, right? So the magnetic field is being cut and current is being induced. Now, how do we understand in which direction the current is being induced? The direction of the induced current is given by Flemings right-hand rule, which we learnt. So according to this rule, if the thumb shows the direction of motion, the forefinger shows the direction of magnetic field, then the central finger will show the direction of the induced current. Okay students, we have just now seen Fleming's right-hand rule, and from Fleming's right-hand rule there's one thing we have understood. If the direction of motion is upwards, then the current is inwards. Now I'm going to use this in understanding how a generator works. Now here, when the coil ABCD, armature coil ABCD rotates in a clockwise direction, AB is going to move upwards. And when AB moves upwards, the current has to be inwards. So let us see how it is produced. The current is flowing. Now the current has gone into B1, right? You have seen the current has entered from B1, gone into the galvanometer, and the current is going from B1 to B2. So let's see this further, right? B1 to B2. Now in the second half of the cycle, now first half of the cycle we have seen the current has gone from B1 to B2. Let's take it further. Now the current has started from B2, right? And now the current is going to B1. That means the direction of current has changed. First time from B1 to B2, now from B2 to B1. Let's see this. Now looking at the same thing in fast forward, the current is once going from B1 to B2, and second time the current is going from B2 to B1. As the direction of current is keeping on changing, therefore the current is called as AC current and the generator is called as AC generator, right? Now generally what happens in a nuclear power station? These people have a lot of water, they heat the water is converted into steam. This steam is made to pass through narrow pipes. The steam goes and hits the armature coil, and the steam makes this armature coil rotate with the speed of 50 cycles per second. Now when this armature coil rotates with the speed of 50 cycles per second, the current will change the direction 50 times per second, and that is why in India the cycle of AC current is 50 cycles per second, right? Now in our house we don't have a galvanometer, we have appliances connected. So here I am going to connect one bulb. When I have this particular bulb, what is going to happen? First time the bulb will receive current from B1. The second time the current will receive from B2. But what difference does it make to a bulb? The bulb only needs current. Whether it comes from here or whether it comes from here makes no difference. So let's see this. The current is going from B1 into the bulb and it has gone to B2. And the second time the current is going from B2 and the current has gone from B2 to B1, right? Children, this answer of AC generator has got 3 important points. So let us see the 3 important points of the working of AC generator, and I want you to remember this point. So let's see the 3 points very carefully. The first point is, when armature coil ABCD is made to rotate in the magnetic field, it cuts the lines of force, and the changing magnetic field creates an induced current. It's the first point. Second point, the direction of the induced current is given by Fleming's right-hand rule. Third point, the current flows through the brush B1 in the first half of the revolution, and the current flows through the brush B2 in the second half of the revolution. Hence, the current is of alternating nature, right? So children, we have seen the working of an AC generator, and we have seen how an AC generator changes the direction of current. But when I was showing you, it was intermittent because you were seeing some parts and you were listening to me. So I'm going to once again take you through the journey of the working of an AC generator, right? And all of you can see this and once again understand how a AC generator works.